He really is. All right. So we missed nothing. So what equation that we know that deals with velocity, m, and also has L in it, maybe?
Oh, where it says that there's a wave in the street.
Yeah, and what is that?
Velocity equals over L. Is it the same thing, no? Or is it different?
Well, tension equals m over L. That's what that says, right? The square root of this. The linear density. It's actually this one, but the u we can substitute with this right here. So cool. So for this second wave, they want us to find the speed of the new wave. They have the same tension. So if I wanted to solve for this velocity, what things would I want to know? Well, I want to solve for the velocity.
Oh, you want to solve the mass and
The mass, and do I know the mass?
yeah, it's 0.003.
Well, let's read the problem. Read it for me. Tell me what it says.
Has a mass of 3 grams, but then you convert it into kilograms.
Okay, and then read the next sentence.
A wave travels at 4 meters per second along the street.
Now read the next super important one.
A second string has the same length but half the mass of the first.
But what?
Half the mass.
So what do I know about this mass right here?
Then it's half.
Yeah, there's one mass, and then there's mass 2, and that's 0.0015. So I know that this is Ft 0.0015. And what am I going to put for L?
44 meters.
44 meters. Why don't I cut that one in half like I did the other one?
So that says that they're under the same.
Yeah, they share the same length. So I want to solve for V, right? So then, what do I need to know to solve for V? What other piece of information do I need to know to solve for V?
I'm sorry.
What other piece of information would I need to know to solve for V? What do you think, John? Tension. Because if I want to solve for this, I want to know everything else. So I need to solve for tension. So it's like, oh shoot, well, how do I solve for tension? Classic Dr. Martyr. Giving me a problem where I need to use one equation to solve for another one. So I have another wave, right? I have 2 waves. I haven't used this 4 yet, right? I have this other wave that's 4. So on the other one, I know that it's the same equation. I know the velocity is 4. What is my other mass? They told me it was 0.003. And then I know that this is 0.44. And they tell you in the problem it's the same tension, right? So you can solve for this tension, and then you plug it into this one, and then I'll give you that one.
You have a lot longer?
Maybe like 5 minutes.
The video should be for
Can I just wait? Okay. So, and again, you classic martyr. So how do I cancel this square root? So this becomes, what does this become? Nope. This cancels out, and then
Oh, 16, sorry.
16. So 16, and I'm gonna simplify this. Cause I really do hate fraction on the bottom. 0.003 divided by 0.44. That's gonna be 0.0068 tension over here. So then I can multiply to cancel out times 16, and my tension ends up being 0.109, and now I can plug that up here. 0.109, and now I can do that into a calculator. So square root .109 divided by point. And when I put it into a calculator, I'm doing this. I put a set of parentheses right here and then another set of parentheses right there to avoid that mistake that happened to you earlier. 0.0015 divided by 0.44. Now I use C. So I put the square root and then parentheses to make it look, that way it's like safe. Or you can do it like longer. You can put like this first and then plug that in. But that's long. If you want to do it like because before all these like that's right.
Oh.
The new speed would be, the speed is 5.6545.
Can I take this or something?
Yeah. You're heading out?
Yeah, my mom's here.
Cool, cool. Thanks for staying. Give me one brief moment just to like see something else. I don't have it anymore. That one. All right, no, that's it. You can head out. What do you do?
John, did you register for speech and debate for next year? Purposefully? Alright, cool, just making sure. It's like my roster and all along. Did you want to do speech and debate or did they stick him in there? I'll bring you we have a separate pack. So I'll bring you like a form with all the information. Okay.
Making this whiteboard just sucks.
Mm-hmm. Why? So it won't erase or does it write?
Because it doesn't write properly. Let me do this one more problem.
Sorry, no, you're still recording.
So this last problem is a car. It's the one for a car. A car is supported by 4 suspension springs, each with a force constant, also known as a spring constant, of 16,200 Newton per meter. the combined mass of the car frame and everything inside the engine, the seats, the passengers is 1340 kilograms. Because of the Warnob shock absorbers, it vibrates up and down. What is the frequency? So we write down our givens first. We know our K is equal to 16,200. We know our mass is equal to 1340, and we're looking, that's all they give me, and we're looking for the frequency. So I think, all right, I need an equation that deals with frequency. So an equation that deals with frequency is going to be 1 over the period. But I don't know the period. So okay, classic martyr, more than one step. How do I find the period? Well, I know what information they give me. Periods I know are m over k, and like look at that. I do know that. So it's going to be, the period is going to be equal to 2 pi. The mass is 1340, but I have 4 spring constants. For my K, I'm going to put 16,200. And for my, and I have 4 of them. So that's what makes this one. But I find the period and then I plug that into, I find the period, then I plug that into the frequency. So it's 2 pi times the square root . $1340 divided by 4 times 16,200. So my period ends up being 0.903. As to find the frequency, it'll be 1 over 0.903. 1 divided by my answer. And the answer is 1.106, which is number 10. Which is number 10. So good luck tomorrow. I'm uploading this as soon as possible.